Hi students, here's your video for example 4 and 5 of your 7.2 Law of Sines notes. We weren't able to get to them in class, so take these notes and we'll have an example in class to go over. So this one says, to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. So the first observation results in, and here's this term that we learned, angle of elevation of 47 degrees. So there's that angle of elevation. And then the surveyor walks 900 meters away and takes another, or marks another sighting, and that's at 35 degrees of angle of elevation. My transit, the person, is also 2 meters high, which is given in the diagram as well. So we want to know the height of the mountain. So if we look at this, we see there's actually three triangles. There is the big right triangle. So let's go ahead. There's this guy, right? Then there's the smaller right triangle. And then here is this obtuse triangle. Now I need to find this height. So I can't use right triangle trig. What I mean by that is like sine, cosine, or tangent because I'm missing too much information. This is only 900 meters for this obtuse triangle, not for any right triangle. But there are some things I can figure out. So if I know that's 47 degrees, and we talked about this in class, then this angle right here has to be 180 take away the 47 degrees because this piece right here is a line, right? So if I go to my calculator, and as a math teacher I should do this in my head, I get 133 degrees. Well, now I can go ahead, if that's 35 degrees, this angle, let me try another color actually. This angle right here, that's the leftover of the triangle. So that would be 180 because it's a triangle, take away the 35 degrees, take away the 133. All right, so let's do that. I'm going to do 180, take away the 35, take away the 133, and I get 12 degrees. So this angle is 12 degrees. Well, the whole purpose of that is because if I focus my attention in just this triangle right here, now I have a full ratio because I have the angle and the corresponding side length. And so that's why I can do sine of 12 degrees over 900 equals. So let's remind ourselves what in the world we're finding. We have to find this height, right? Well, so that means either you want to find this hypotenuse for the smaller triangle or the hypotenuse for the larger triangle. It is up to you. You will still get the same answer if you do your math correctly. So for me, I'm just making a random decision. I'm going to find the hypotenuse for the larger triangle. So that's why I would do sine of 133 degrees. And that's over our unknown. So that's this piece. Or some of you could have done sine of 35 degrees over the unknown. So if I cross multiply, all right, then I'm going to divide by that sine of 12 degrees. Go and rely on my calculator. So 900 times sine of 133 And just to make this easier, I'm going to push enter, and then I'm going to alt divide it by, or no, I'm not, answer, divide it by sine of 12 degrees. So I get that my hypotenuse for the large triangle is 3,165.85 meters, because those are the units we're working in. But that's not giving me the height. So what I want to try now is, okay, well, now I'm going to look, it's going to get a little messy, but now I'm looking in this entire right triangle. So I have this angle of 35 degrees. I have this value, and I'm looking for this unknown. And so that's why I can go ahead and do, okay, well, because I'm in a right triangle, sine of 35 degrees equals opposite, which is my unknown, which we labeled as our height, over our hypotenuse. So then our height is 3,165.85 times sine 35 degrees. And once again, I'm going to use this entire answer and not just the rounded one, and of 35. And we get about 1,815.86 meters is the height. Now, is that our answer? Remember, the person is 2 meters high. So what should we do with that 2 meters? Well, that's being taken into effect in how high this mountain is. So that's why it would be 1,815.86 meters, and you take away the 2 meters. So this tells us that the mountain is approximately, because I did estimate, approximately 1,813.86 meters high. Okay. So now let's do an example, very similar, where we don't have the diagram. So Pat needs to determine the height of a tree before cutting it down to be sure that it will not fall on top of a nearby fence. The angle of elevation of a tree from one position on a flat path is 30 degrees, and the second position is 40 feet further, and it's 20 degrees. What is the height of the tree? So let's go ahead and give us, since I have colors, it's kind of fun, a good old diagram. We have, here's the person, and we're looking at the top of the tree here. We move in 40 feet closer or further, however you want to say that. So let's go here. We look at the top of the tree again, and then this is going to form a right angle. So realize that the height of anything always has to form a right angle. That's how we measure it. Now, the one confusing part is, where do you put the 20 degrees and the 30 degrees? So think about it. When you move closer to something, you have to look up more, right, to see the top of it. So that's why the bigger angle will go closer in, where the smaller angle is further out. All right. So I would pause this video and see if you can do this one on your own, and then come back and see if you got it correct. So it's a very similar process. We don't know the height, and we're looking for either the larger hypotenuse or the smaller one. This one, I'll just do the smaller one just to show you that it doesn't matter. And I'm going to go ahead and start filling in some unknowns. So let's go ahead with the blue. So this has to be 150 because this is a line. Well, 150 plus 20 is 170, so this has to be 10. And you can fill in the rest, and then this is 60. All right. Well, I do have a full ratio with this 10 degrees, and the corresponding side is 40. So sine of 10 degrees over 40 equals, well, and I decided that I wanted to solve for that one. So that's why it has to be sine of 20 degrees over x. Cross multiply. And we get 40 times sine of 20 degrees over sine of 10 degrees. Go back here. All right, 40 times sine of 10 degrees. Close that. And if I want the whole thing in my numerator, I'm going to put the whole thing in parentheses. Divided by sine of 10. What happened here? Oh, I need to put in, let's see if I can get there, 20 degrees. Okay, so 40 times sine of 20 degrees divided by sine of 10 degrees is 78.78 or 9 feet. But that's not what you want. You want this, the height there. So that's why now I'm in a right triangle. So I can use right triangle trig. I have to use sine since when I stand at 30, I'm looking for the opposite, but I'm given the hypotenuse. So it's sine of 30 equals opposite, which is your height, over your hypotenuse. And do that math. And let's see what we get. So again, I'm going to use the whole answer times sine of 30. And I get 39.39 feet. What is true, it's kind of cool, of that triangle? It's a special right triangle. It's a 30, 60, 90 triangle. So this is kind of cool. We found the hypotenuse, right? If you wanted to find the height based off just special right triangles, well, remember your height here is across from the 30, so that's known as your short leg. So I could have done 78.78 divided by, well, it's half of it, right? Remember, your hypotenuse is double your short leg in that special right triangle business. So let's see what happens. I'm going to take this. Let's get out of here. Keep going. Get rid of you. Okay. Oh, wait. I went too far. Okay. I'm just going to do 40 times sine of 20. Close that guy. Divide by sine of 10. Okay, if I divide this by 2, let me get my answer in there. Divide by 2, we get the same answer. So it's pretty cool knowing special right triangles. Okay, so our answer is the height of the tree is about, because you did do some rounding, 39.39 feet. Okay, see you next time.